No. Like and subscribe. Alrighty, team. So today we're going to go through nominal and effective interest rates. Nominal is really just another fancy word for annual interest rate. So far when we've been working with simple and compound interest rates are generally given to us with PA on the end, which we know means per annum, so they're yearly rates. But as we know, sometimes interest gets calculated in different time periods. And in some of the questions that we did in, say, 8E and, for example, we were talking about times when that rate was, say, monthly, so we were dividing the rate by 12. This box on the screen at the moment has a whole list of different compounding periods, because these are different words that you might see, and it tells you then how many times that rate would compound in 1 year. And the stuff in the bracket is just a little bit of extra information because it's some questions that you might have. So where it's got biannually, we know that the prefix bi means 2, like a bicycle has wheels. So biannually means it's going to compound twice per year. Quarterly, for example, that means 4 times per year. And it's important to note then that each quarter has 3 months of the year in that quarter. Monthly, 12 times per year, and we still divide it by 12, even though we know some months of the year have different number of days. Fortnightly, there's 26 fortnights in a year. Weekly, there's 52 weeks in a year. And daily, we work off 365 and just ignore the fact that leap years exist. So just divide by 365. For us to convert a nominal interest rate to a different compounding rate for these periods, it just means we take that nominal or annual interest rate and divide it by that number for how many times it's going to compound in a year. So if we look at question 1, it says here an investment account will pay interest at the rate of 3.6% per annum, and it asks us to then convert this to a quarterly rate, a monthly rate, and a weekly rate. If we're working this out then as a quarterly rate to start with, we did say before, quarterly compounds 4 times per year. So we're going to take 3.6 and divide that by 4. That's going to become 0.9%. You can do that in your calculator. If it's monthly, that means we're taking that 3.6 and we're going to divide that by 12. So if I just head to that main menu, 3.6 divided by 12, it's going to give me 0.3%. And lastly then, if it's a weekly rate, that's then saying that we do 3.6 divided by 52. And for now, let's write 0.07%. More likely than not, we will just be working with, say, monthly periods, so just dividing things by 12. And if there are like 3 decimal places, then don't round your answer, but write all of those decimals with your answer so that you keep as much accuracy as possible. So they're going to more than likely give us examples where we will just keep all those decimal places because it's going to be a finite decimal, so one that ends rather than recurs. If we scroll on down to question 2 then, question 2 says to us that an investment compounds weekly at a rate of 0.08% per week, and then asks us to determine the annual interest rate. So that annual rate then requires us to take that weekly rate of 0.08 and times that by 52, because there's 52 weeks in the year. And we get 4.16%. And again, I'm going to keep those decimals there and write 4.16. Hopefully that's all G so far. That's the easy part. Where things get spicy is now talking about effective interest rates. I want you to think of the effective interest rate as almost being like the average interest rate for the year, because what is happening is we know if things compound more frequently, then we know that we get that interest on interest benefit occurring more often, and so we get extra interest earned throughout that year period, okay? What that means is my investment's going to increase much quicker, but because things might compound with different rates and different time periods, it's a little tricky for me to compare what's the best option for me to pick. And I could work out what all the interest is, but what I can also do is calculate what's called an effective interest rate, and that gives me the average, the relative rate for a year. And so I can just get the effective rate across 1 year, and therefore I can compare two yearly rates and just work out from there which one is then the better option for me, okay? So this example here we're going to go through. Let's say you invest $5,000 at an interest rate of 4.8% per year, and you have the option to have the interest compound annually, quarterly, or monthly. If we look at this, annually, quarterly, monthly, I've got 4.8% for that annual rate, and then I've written quarterly 1.2% because that's 4.8 divided by 4, and for monthly I've got 0.4% because that's 4.8 divided by 4. All those numbers under there now show you how much interest is earned in 1 year, and I will show you where those numbers have come from so you can believe me. If we convert these into some sequences, for example, so I'm going to head to the sequence menu. Hopefully you agree with me that I would be using a sequence of VO equals 5,000 and then VN plus 1 equals capital R times VN because we're compounding. And in the case of the annual rate, my capital R is going to become 1.048. So in my sequence menu here, I'm just going to change this to be 1.048. I've got 5,000 there as my initial amount, and I'm going to, oh, I've put too many zeros in. Yep. And I'm going to run that. Because we're talking about 1 year, we can see at the end of 1 year, it's worth $5,240. So my account is increased by 240, and that's why I've got that written down in the interest box, which is here. Okay. If I do that same thing for the quarterly stuff, that means me changing my recurrence relation now to be 1.012, because that would be my capital R value with a rate of 1.2%. If I run that, remember quarterly means it's going to compound 4 times in the year. So I need to look at N4 because that's going to be the value at the end of 1 year. And if I look at N4, the total on here is $5,244 and more precisely 35 cents in that bottom box. The amount of interest is that minus 5,000, so it's $244. So we can already see quarterly to yearly, I've earned an extra $4 of interest. Finally, for monthly, R value of, well, little r of 0.4 means my capital R is going to be 1.004. So if I change that in here and run it, and I now need to look all the way down at number 12 because there's 12 months in 1 year. And if I'm down here at that, I can see it's 245.35. I've written a number wrong here, but you get the gist. So we can see that that monthly one has increased a little more as well. Now, the effective annual interest rate is us calculating that amount of interest as a percentage of how much money we started with originally. So if we look at how much interest is earned in that 1 year, and if I divide it by what the original amount is, I'm going to get what that effective interest rate is. So for the annual rate, it's still 4.8% because it's already just 1 year. For me to look at the quarterly data, that would be me doing 244.35 and dividing that then by 5,000, timesing it by 100 to make it a percentage, and I get 4.89%. For me to do that for monthly, it would be me taking that 245.35, dividing that by 5,000, timesing that by 100, and I get 4.91% there. So in comparing these three from those effective interest rates, which is like that average yearly rate, so to speak, we can see that that monthly rate then has a rate of 4.91%, which is 0.1% or 0.11% higher than the annual rate. From here though, that's a bit of a laborious process for us to continuously calculate the interest and then convert it back to a rate each time. So there's actually a formula and some stuff that we can do on the calculator that then allows us to just calculate that rate straight away, regardless of how much money is invested and things like that. We can just shortcut straight to the rate. So I'm going to stop here, watch my next video to see that. Thanks.